Hello GATE aspirants, welcome to part 2 of GATE Thermal and Statistical Physics series. Question 4. A Carnot cycle operates on a working substance between two reservoirs at temperature T1 and T2 with T1 greater than T2. During each cycle, an amount of heat Q1 is extracted from the reservoir at temperature T1 and amount Q2 is delivered to the reservoir at T2. Which of the following statement is incorrect? Now work done in one cycle is Q1 minus Q2. So this is our working substance. This is reservoir at temperature T1. Heat Q1 is transferred here. Heat Q2 is rejected, and this is at temperature T2, and this is the work done. So work done is difference between Q1 minus Q2. So this statement is correct. Also Q1 by T1 is equal to Q2 by T2 for Carnot cycle. Option C is entropy of the hotter reservoir decreases. Now this is reservoir, heat reservoir, and for it this process is a reversible process. So if it is a reversible process, then that means delta S is equal to 0. So there will not be any entropy change for hotter reservoir. So option C is correct. Next question. In the first order phase transition, at the transition temperature, specific heat of the system. So specific heat, we have dq is equal to mc dt. So C is equal to dq by mdt. Now here we are considering first order phase transition. So here pressure and temperature, they remain constant for first order phase transition, and heat is either absorbed or released, and during this there is phase of change of phase, and it is first order phase transition. For this, Gibbs free energy is also constant. Now we have dg is equal to v dp. It is continuous function. So dg is equal to v dp minus s dt. So dou g by dou p at constant t is equal to v, and dou g by dou t at constant p is equal to minus of s. So these first derivatives of g, they are going to be discontinuous. So v and s are discontinuous at transition point. Now this process is occurring at constant temperature, so it is isothermal process. Isothermal means delta T will be 0. So here dt is equal to 0, that means this C will tend to infinity. So specific heat, it will diverge, and entropy, that is S, will have finite discontinuity. So here option B is correct. Next question. If the isothermal compressibility of a solid Kt is 10 raised to minus 10 Pascal inverse, the pressure required to increase its density by 1% is approximately. Now isothermal compressibility is minus 1 upon V dp dV by dP at constant temperature. Now we also know density is inversely proportional to volume. So delta rho by rho is equal to minus of delta V by V. But from here we can write Kp into delta P is minus dV by V. So this is equal to Kt into dP. And this is given, this is 1%, so 0.01. This is equal to Kp is 10 to the power minus 10 into dP. So from here dP is equal to 10 to the power 8 Pascal. So option C is correct. Next question. A system of n non-interacting and distinguishable particles of spin 1 is in thermodynamic equilibrium. The entropy of the system is. Now entropy is equal to Kb and summation over of ln of omega, where omega is number of microstates. It is a spin 1 particle, so it can have z component of it can be minus 1, 0 and 1. So number of microstates is 3. So number of microstates omega is equal to 3. So S will be equal to There are n such particles, so we have to multiply by n. Into we have kb and ln of 3. So here option D is correct. A system has two energy levels with energies epsilon and 2 epsilon. The lower energy level is 4-fold degenerate, while the upper level is doubly degenerate. There are n non-interacting classical particles in the system, which is in thermodynamic equilibrium at a temperature T. The fraction of particles in the upper level is. Now let us first write down partition function. Partition function is summation over gi e raised to minus ei upon kt. So where gi is its degeneracy. For lower state it is 4 and its energy is epsilon. So this will be e raised to minus epsilon by kt. For the upper level it is 2, e raised to minus 2 epsilon by kt. So P is equal to the probability that particle is in upper state is equal to P of 2 epsilon. This will be equal to its value. So that is 2 into 2 raised to epsilon by kt upon z, and z is 4 e raised to minus epsilon kt plus 2 into e raised to minus 2 epsilon by kt. So here option. So here we have to just solve it again. So divide by 2 into e raised to minus 2 epsilon by kt throughout. So in the numerator it will be 1. So this will be 1 plus 4 by 2 is 2 and e raised to minus epsilon by kt upon minus 2 epsilon by kt. So this will be minus 1 plus 2. So this will be plus 1. So epsilon by kt. So here option B is correct. So these were all the questions from GATE 2011 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.